Hello, everyone. You're all welcome to today's class. I hope you're all doing great. Okay, so in today's class, we'll be talking about circle theory. But before we do so, I would love us to quickly look at some properties of a circle. And with that, we'll be able to do our circle theory without any issues. Okay, now let's move into it. Now I'm going to be sharing my screen with you so you can see every bit of it. Okay. So the very first thing we have here is parts of a circle. Parts of a circle. So the first thing we have here, we have the diameter of a circle. If you look closely, you see a diameter of a circle over there. You see diameter of a circle here. So every line that cut a circle into two equal halves is what we refer to as diameter. As you can see, this line is cutting the circle into two equal halves. This is the line. So it's actually called a diameter. The next thing we have here on this circle is the radius. On the radius here, on the circle here, you see a radius. Now, you see that the radius runs from the center of a circle to the circumference. So every line that runs from the center of a circle to the circumference over here is what we refer to as the radius. I know you already know all this. Now, the next one we have is the chord. The chord is any line that cuts a circle at any point, but not at the center. Now you look at this, you see that the chord is cutting the circle at this point, now forming two segments. Now we have the major segment, this entire place is the major segment, and this other part of it is the minor segment. So a chord can only cause segment, can only cause a major segment and a minor segment, while a diameter causes a semicircle. So once a diameter cut a circle, we have two semicircles. The next one we have is the tangent. So any line that touches the circumference of a circle is what we refer to as the tangent. As you can see, this line right here is touching a part of a circle, causing what? A tangent. So this is a tangent. Let's move forward. Now there are some things we should take note of while talking about circle theory. So these are the things we have to take note of. So the first thing here is that angles in a triangle is sum up to 180 degrees. All the angles in a triangle are sum up to 180 degrees. So this is what we mean. This is what we mean when we say angle in a triangle is sum up to 180. If you're having a triangle, let me draw a triangle for us. If you're having a triangle and this angle happens to be our x, this one happens to be our y, and this happens to be our z. What this is saying is that the sum of x plus y plus z is equals to 180 degrees, because these are the only three angles we can find in a triangle. Angle x, y, and z. The sum of it should give us 180 degrees. So let's take note of this. That is number one. The second one is that angle on a straight line or angle on a line is sum up to 180 degrees. This is what that means as well. If we're having a straight line and we have some angles that's being formed on it, like this, let's call this angle angle A, call this one angle B, then call this angle C. Then we can say that A plus B plus C will give us 180 degrees. All right, moving forward. So the next one we have here is the isosceles triangles. Isosceles triangles. Now, you should know that isosceles triangles are angles that two parts or two sides of it are equal, and two angles inside are also equal. Now, having this, let's say we have a isosceles triangle here. This side and this side, they are equal. This angle here and this angle here, they are also equal. Okay, that's to say that if here is 5 cm. Here it will also be 5 cm. And if here is 60 degrees, here will be also 60 degrees. So this is what isosceles triangle means. Any triangle that two sides of it are equal and the two base angles are also what? Equal. Now the next one we have is that angle about a point sum up to 360 degrees. So this is what that means. Let's say we have angle at a point in this manner. We have angles like this. Now this is a point. This is a point. Now we have angles surrounding it. Let's call this angle P. Let's call this one Q. Call this X. Then call this Y. So what this is saying that if we should sum all these angles together, if you're having X plus Y plus P plus Q, the sum of it should give us 360 because it's angle at a point. All right. Now we've known these basics. Now let's go into our first um theory for today. Mind you, we're just going to be looking at one of these theory for today. Then in our next class, we look at the next theory. Now, in this first theory, it states that angle at the center of a circle is twice the angle at the circumference sustained by the same arc. Now, looking at this circle here, you can see that we have two angles formed on it. We have this angle here. I also have another angle that is being formed on it. Now, looking at this, from what the theory is saying, that the angle at the center of a circle is twice the angle at the circumference. What that is saying is that the angle that is formed at the center here is 2 times of the angle that is formed at the circumference over here. This is circumference of a circle and the center of a circle. Now, this can only work, this can only be valid if they share a common arc. If they share a common arc in such a way that the points, the 2 points that is forming the angle formed at the circumference is also the point that is forming the angle that is being formed at the center of the circle. Now, this is an arc, and this is also an arc. It's an arc because it's forming this angle like this. If we should label this now, we can have A here, B here, and C here. So now, this arc now is now forming angle A, B, and C. Let's put this one here to be O. Then we can now say this same arc is also forming angle AOC. Okay, so here we are having angle ABC, and we're also having angle AOC. All right, so what this theorem is saying is that the angle that is formed at the circumference, which is angle ABC, is 2 times of the angle that is being formed on the circumference. Sorry, at the center of the circle. That means this will be equals to um sorry. Okay, so this what he's saying is that the angle that is formed here, angle AOC is 2 times of angle A, B, and C. Okay, so this is what this thing is saying. Now let's move forward. Let's look at some more example on how to go about this. All right, if you look at this circle here, you can see that you can see that we have two angles here as well. We have an angle at the center of the circle, also have another angle at the circumference. You see that the angle at this center is twice the angle over here. If you look at the comment here, say arc AB sustained at angle of 50 degrees at C. That will tell you that this angle here on this arc A and B is forming 50 degrees, and this and the one at the center is actually twice of this. If you look at these solvings here, you see that we have 2 times 50.2 degrees will give us 100.3 degrees. If I should increase this angle, you see that will still be giving us 2 times the angle at the circumference, still be giving us 2 times of that at the center, right? As you can see, we are still having a angle at the center is still twice of that in the circumference. Okay, so now let's do some workings so you can see and know how this works. All right, so over here we have some examples. We have some work to do over here. All right, so we have this. I think this is one of the example, or one this is actually the circle theorem one. This is the number one, and also this and this. So I'm going to be doing two of this for us. Then I think you have to do this by yourself. Okay, so let's start with this. So on this one, we can see that we have 46 degrees that is being sustained at angle A, B, and C. So on this one, we are having angle A, B, C to be equals to 46 degrees. And we are having our angle A, O, and C to be A. This is what is being given here. So what are we looking for here? We are going to be looking for the angle at the center of the circle. Remember, from our definition of the first theory, it says that the angle at the center is twice the angle at the circumference. So with that, we cannot say that our angle ABC, cannot say that our angle AOC is equals to 2 times of angle ABC. All right, because it says angle at the center of the circle is twice of that of the circumference. So that's why we have angle AOC to be the angle at the circumference at the center, and we have our ABC to be the angle at the circumference. So with this now, we can now go ahead and say that our angle AOC will be equals to 2 times, remember our angle ABC is 46, which is 46. Remember our AOC is given to us here to be what? A. So we can just change this to be A. This will be equals to 2 times 46. That means you're going to be having 92 degrees. That means this angle here is 92 degrees. Now, if you look at A, you see that 92 is actually twice of 46 degrees. So that's how we got this answer. So let's do this one. Let's do this so you can do this by yourself. All right. Looking at this one, the same thing I just explained earlier, that the angle at the circumference is twice at the angle at the center of a circle is twice the angle at the circumference. So let's quickly do that. So in this case, we are having our Our angle ABC is equals to x, and our angle AOC is equals to x plus 22. Remember, we said that the angle at the center of a circle is twice the angle at the circumference. So because of that, we can now say that the angle at the center here is x plus 22. Remember, what you're looking for here is the value of x. This will be equals to, remember, we said that the angle at the circumference at the center is twice of the angle at the circumference. That means we have to multiply the angle at the circumference by 2. This will be 2x. So we can now have x plus 22 equals to 2x. Now you can collect like times here. Collecting of like times. Collecting of like times, taking the ones that have x to one side and leaving the one that doesn't have x on one side. So we have we're going to be having 22 equals to 2x minus x. All right. At this point, we can now say that 22 will be equals to 2x minus x. We're going to be having x. That means our value for x is 22. 22. So if you come back to this place, you see that 22 plus 22 will give us 44. And x here is just 22. 44 is actually twice of 22. 44 here, 22 here. Now you can see that this place is twice of this place. Now we want you to do this. You have to do this and submit your answers. Let me see how well you understood the class. So thank you very much. Thank you very much. In our next class, we look at the second theory. So thank you so much. Don't forget to do your assignment and submit. Thank you. Thank you. All right. Have a nice day.